ionization vacuum gauges, they are used for the measurement of pressure in the range from 10 raised to the power minus 4 to 10 raised to the power minus 9. Torr is the unit of pressure. So such very low pressure measurements for that ionization vacuum gauges are used, and they are available since 1916. So they were developed in the year 1916, and from since then they are used to detect the pressure levels. Now these ionization vacuum gauges, they use the process of ionization to measure the pressure. Now all the types of ionization vacuum gauges, they detect an electric current, and this electric current is generated due to the ionization of the gas whose pressure we want to measure. Okay, so this gas will consist of the gas molecules, and due to the ionization of those gas molecules, an electric current is generated, and that electric current is detected by the ionization vacuum gauges, because this current is proportional to the ionization of the gas. Okay, because due to the ionization of the gas molecules, the electrons will be generated, and the more the number of electrons generated, more will be the electric current. Okay, so the ionization vacuum gauges, they work on the principle of detecting an electric current which is generated from the ionization of the gas whose pressure we want to measure. Now, what is this ionization, and why due to ionization and how due to this ionization of the gas molecules the electric current is being generated? Now, ionization is defined as the process of removing an electron from an atom. Okay. So ionization is the process of removing an electron from an atom, producing a free electron and a positively charged ion. If we see a structure of an atom, so in an atom we are having the nucleus, and around that nucleus we are having the orbits in which the electrons are revolving. In the nucleus, we are having the protons plus the neutrons, and around this we are having the electrons. So this is an atom which is a neutral atom. Okay, in this the number of protons plus neutron is equal to the number of electrons. Now, when ionization is done, then because first this atom is in neutral condition, when ionization is done, then an electron is removed from it. Okay, so atom will have its nucleus, it will have electrons, but one of the electron is being removed, so we are having an electron separated from it. So now this atom will be a positively charged ion, because the number of electrons and number of protons and neutrons, it has changed. Okay, so the atom, it will become a positively charged ion, and we are having an electron which is moving in a free space. So due to the ionization, what this ionization process is, it is a process of removing an electron from an atom, producing a free electron and a positively charged ion. Now there are various methods of doing this ionization. Ionization can be done by providing very high energy to the atom, okay, or due to the collision of the atoms also free electrons are being produced. Now, because the ionization vacuum gauges, they are based on the ionization of the gas whose pressure we want to measure. So to convert a gas molecule into a positive ion by the ionization process, we have to remove an electron. Now, how this electron can be removed? If an atom or molecule is supplied with the energy equal to its ionization potential, so our main principle here is to generate the positive ion, to convert a gas molecule into a positive ion by removing the electron. So this electron can be generated if we know that in an atom or molecule, when we supply an energy which is equal to its ionization potential, so the electron which is present in the outer orbit of the atom, it will escape and a positive ion will be created. So in this process, suppose ionization we are doing, so to this neutral atom, if we are providing an energy which is equal to its ionization potential, so when energy is given to it, so due to that energy, the electron which is present in its outer orbit, okay, there are various orbits in the atom in which the electrons are moving, but the electrons which are moving in the outer orbit are called the valence electrons. So those electrons, out of those electrons, one of the electron will be removed because we have supplied an energy which is equal to the ionization potential. So due to that process, and free electron and a positive ion will be generated. So a gas molecule will be converted into a positive ion and a free electron by providing its an energy which is equal to its ionization potential. Okay. Now the approximate energy, that is approximate value of this ionization potential, is 5 to 30 electron volt. Okay. Now we have to apply the ionization potential, okay, and this energy, its value is from 5 to 30 electron volt. Now if this energy is provided at a constant rate to the gas molecules, and if we are having a sufficient amount of atoms or the gas molecules present in an area, and we are continuously providing at a constant rate this much amount of energy to the gas molecules, so at a constant rate ions will be produced. Okay, if energy is provided at a constant rate and sufficient amount of atoms or molecules of the gas are present, then at a constant rate the ions will also be produced. So a sufficient amount of positive ions will be produced if we are providing the ionization energy at the constant rate. this ion stream, because more number of ions are being produced here, so this ion stream, if it is directed towards a cathode, okay, because ions are the positively charged ions and cathode is negative, so the positive ions, they will be attracted towards the cathode, okay, and due to this ion stream, in the cathode, current will start flowing, okay. So current that flows through this cathode, that is proportional to the pressure of the gas, because more the number of atoms or molecules present in that area, more the number of ions produced and more the current flowing through the cathode, okay. So we can say that indirectly this current which is flowing in the cathode is proportional to the pressure of the gas, okay, because pressure is more, so more number of gas molecules are present. If pressure is less, then less number of gas molecules are present, and the number of gas molecules is defining the current which is flowing through the cathode, okay. So all these ionization vacuum gauges, they are based on the principle of measuring the current which is generated due to the ionization, because due to ionization, positively charged ions are produced, positively charged ions get attracted towards cathode, cathode starts flowing the current, and that current is proportional to the pressure of the gas, okay. So that is the principle of working of the ionization vacuum gauges. Now the initial ion current which is flowing, that is proportional to the molecular weight of the gas. Now as the molecular weight increases, the initial ion current also starts increasing. Now all the various types of ionization gauges which are used for the pressure measurement, they can be distinguished from each other by the method which is used by them to produce the ions, because our main purpose is to produce the ions by the process of ionization. So what method is being used by the vacuum gauge to produce that ions? So that is going to distinguish the ionization vacuum gauges. Now here I have said that the initial ion current, it is proportional to the molecular weight. So if any gas is having a higher molecular weight, so large amount of current will be flowing. If it is having less molecular weight, then less amount of current will be flowing. So for calibration of these ionization gauges, either dry nitrogen is used or air is being used. Okay. So calibration can be done by using the various types of gases, like the dry nitrogen is most probably used and air can be used. Now as these ionization gauges, the types of ionization gauges are depending upon the method which is used by them to produce the ions. So based on that, there are two types of ionization gauges. One is the hot cathode ionization gauge. Another one is cold cathode ionization gauge. Okay, so there are two types of ionization gauges, hot cathode and cold cathode ionization gauge, which are different from each other on the basis of the method which is used by them to produce the ions of the gas molecules. Okay, first we will start with the hot cathode ionization gauge. Let us first see the diagram of this. So this is the circuit diagram of the hot cathode ionization gauge. In this you can see here we are having a box in which the plate and heated cathode is being connected. To the plate we are having a meter, so this is going to measure the plate current, and here we are having the heated cathode, and in between it we are having the grid. In this box we are having the gas molecules. Okay, so first of all, these gas molecules, they will be excited, some energy will be provided to them so that the free electrons and positively charged ions are being generated. Positively charged ions, they will be attracted towards the cathode, so current will start flowing, and the remaining free electrons, they will be attracted towards the plate. So due to that also currents will start flowing, and that will be the plate current. Okay, in this box we are having providing the vacuum. Okay, so let's see it's working, that how it measures the pressure by measuring the electric current. So first of all, the cathode which is heated, that is going to generate the electrons. These electrons are generated and they are accelerated towards the grid. Okay, now this grid is positively charged, so electrons which are generated by the cathode, they are attracted towards the grid. So some of the electrons are captured by the grid, and due to those electrons the current will start flowing, and that current is called the grid current. Okay, now some electrons are captured otherwise, and the remaining electrons, those electrons, if they are having high kinetic energy, they are going to pass through. Which are having low kinetic energy, they will be absorbed by the grid. Now, the electrons which are having high kinetic energy, they are going to cause the ionization of the gas atoms. Okay, because the electrons are having very high energy. When those electrons strike with the atoms of the gas molecules, ionization will occur and more electrons will be produced. So due to the ionization of the atoms, free electrons plus positive ions are generated, and those positive ions, they are captured by the plate, generating the plate current. to the ionization of the gas atoms, free electrons plus positive ions are generated. Those positive ions, they get attracted towards the plate, which is kept at a negative potential. So positive ions attracted towards negative plate, and due to those positive ions, current will start flowing, and that current is called the IP current or the plate current. So we will be having 2 meters. 1 meter is the meter which is measuring the plate current, and another is measuring the grid current. Now grid current is due to the electrons which are generated by the cathode, and plate current is due to the positive ions which are generated due to the ionization of the gas molecules. So our main purpose is to measure this plate current, because that will be proportional to the pressure of the gas inside this box. Okay. So it is being found that the pressure of the gas is proportional to the ratio of the plate current to the grid current. So pressure is equal to the plate current and the grid current. Okay. And here we are having a constant of proportionality, which is S. So this was the hot cathode ionization gauge, because here the cathode is being heated, and due to the heating up of the cathode, electrons are generated. These electrons, some of the electrons are absorbed by the grid, some of the electrons which are having very high kinetic energy, they are going to cause the ionization of the gas molecules, and due to ionization, positive ions are generated which are being attracted by this plate, and due to that, plate current will start flowing. So by measuring the plate current and the grid current, we can find out the pressure of the gas inside this box. Now here S is the constant of proportionality, and it is called the sensitivity of the pressure gauge. Now, if we see the value of this sensitivity for nitrogen, then it is 20 torr inverse. But for other gases, the exact value of this sensitivity can be found out by calibrating it with the help of different gases. And because this sensitivity, it depends on certain factors. It is a function of the geometry of tube, and the gas filled in the gauge. So this constant of proportionality, or we can say sensitivity, it's a function of the geometry of the tube and the gas which is filled in the gauge. So for different gases, it will have different values, and we can get the value of pressure of the gas by putting the value of sensitivity and plate current and the grid current in this formula. Now let's come to the pressure range that can be measured with the help of this hot ionization pressure gauge. It can measure the pressures from 10 raised to the power minus 3 to 10 raised to the power minus 8 mm of Hg. So this is the pressure range for the hot cathode ionization vacuum gauge. Now comes its disadvantages. Let's see that what are the disadvantages of this type of ionization gauge. Now, because these gauges are used for the measurement of very low vacuum pressures, so the filament, because here we have seen that cathode is heated up and this cathode is generating the electrons by using the filament. Okay, so filament of the cathode will burn out quickly if it is heated before the pressure is at a low value. Okay, so when the pressure is coming to a very low value, before coming to that level, if the filament is heated earlier, so that filament is going to burn out very quickly. So that is why in such cases the other vacuum gauges like the Pirani gauge and the thermocouple gauges, they are used, so that when the pressure come to a low value, then the filament is heated up and it is going to generate the electrons. Okay, so that is the main disadvantage of the hot cathode type of ionization gases. That in these cases the filament is going to burn out very quickly. Now, in these type of ionization gases, there is a need of an automatic cutout circuit which is protecting the ionization tube if there is any system leakage or breakage of the uh, gauges. Okay, so in that cases, in order to protect the ionization tube, there is a need of a automatic cutout circuit. Also, these gauges must be critically installed, particularly in the case of absorbed gases, must be eliminated. So their installation should be very proper. So for the main problem is to absorbed gases. The gases which are absorbed in the tube, they must be eliminated. Otherwise, those gases are going to give wrong results or inaccurate results when another measurement is being done. Okay, so every time the measurement is to be done, the gases are to be completely removed and then only the measurement should be done. So these were the disadvantage of this hot cathode type ionization gauges. Now here the voltages which are provided to the cathode and the grid and the plate. So those voltages are in the range from 50 to 300 volts. Now in the disadvantage, we have seen that the main problem is the heating up or the burning out of the filament. So to remove this problem, the second type of ionization gauges, that is the cold cathode ionization vacuum gauge, is being used. So let's study the second type of ionization gauge. Now the difference between the hot cathode and cold cathode type is the method which is used to produce the ions. In the hot cathode, the ions are produced by the thermal ionic emissions. Okay, we are heating up the cathode. Cathode is generating electrons. Electrons are further generating the positive ions, and due to that current is being generated. So electrons are generated due to the thermoionic emissions. Okay, so in hot cathode type, the ions are produced by thermoionic emissions, whereas in cold cathode ionization vacuum tube, a very high potential field is used to generate the ions. So in hot cathode, the electrons are coming out from the cathode when it is heated. So it's due to the ionic emissions. Whereas in cold cathode, high potential field is going to withdraw the electrons from the surface of the electrode. Now, as in the cold cathode type of ionization vacuum gauges, a high potential field is being used. So the rate of emission of the electrons is very slow as compared to the hot cathode type. So to overcome this problem, and because the rate of emission is very low, so the collision frequency between the electrons and the gas molecules is also very less. So if collision frequency is less, then the rate at which the positive ions are being produced, that is also lower, and the current which is generated, that is also low. So because high potential field is used, so rate of emission of electrons is lower and rate of emission is less. It means the collision frequency between the electrons and the gas molecules or the atoms of the gas, that will also be lower. Also, if the electrons are traveling in the straight path, so in straight path if they are traveling, then collision frequency percentage will be almost reduced. Okay, so the current generated will be less and we will not get a high output, very low output will be generated. So to remove this problem, we have to increase the path of the electron, because earlier the electrons were traveling in the straight path. Okay, so because they are traveling in straight path, so the chances of their collision with the gas atoms, that will be reduced. Okay, so we have to increase the collision frequency, we have to increase the path of the electrons. So to increase the path length of the electrons, a magnetic field is created between the tube, and if around the tube, due to the presence of the magnetic field, the electrons, they are going to deflect. Okay, and they are going to move here and there, and their path will be changed. The path length will be increased, and the electrons, they will start moving in a spiral form. Okay, so this magnetic field, because magnetic field is present and electrons are moving in that magnetic field, so due to the effect of this, the electrons are going to deflect. Okay, and the electrons, they will move in a spiral form. Okay, so this spiraling action, it is going to increase the path length of the, and if path length is increased, it means that the collision frequency also increases. So the percentage of collision between the atoms or the gas molecules and these electrons, that increases. Okay, so if collision frequency increases, the collision of electrons and atoms is increasing, more number of positive ions are being generated, more electric current is generated, and we are getting a high output. High output means that the sensitivity is increased. So a higher sensitivity can be increased by not only having a potential field but also having a magnetic field in the cold cathode type ionization vacuum gauges. So that provides a higher sensitivity to these types. Now, if we see the construction of these cold cathode type ionization gases, it consists of two cathodes and one anode. This anode is having holes in it. Okay. So in the hot cathode type, we were having only one cathode, but here we are having two cathodes and one anode. Let us see the diagram of this. So this is the construction of the cold cathode type ionization gauge. So in this you can see that it is having two cathodes and one anode. Okay. Now the magnetic field is present in between it, which is of the magnitude minus 1500 Gauss, and due to this magnetic field the cathode is generating the electrons. Okay, high potential field is applied in between there. So due to that potential field the electrons they are extracted from the cathode. Okay, now these electrons they enter into the anode, and here we are having the magnetic field. So electrons are going to move in a spiral direction. Okay, in the form of a spiral. So due to that, because here we are having the vacuum or the gas molecules are present, so collision is there between the gas molecules and the electrons, and due to that positive ions will be generated. So due to the presence of positive ions the current will start flowing, and this current is measured by the microammeter. Okay, and this current is proportional to the pressure of the gas. If pressure is more, then more current will be there. If pressure is less, then less current will be there. So that is the working of the cathode type of ionization vacuum gauges. So you have seen that the method of generating the ions is different in both the cathode type and the both the hot type and the cold type of gauges. Now let's see the advantages of the cold cathode type. So the advantages of the cold cathode type are that their cost is less as compared to the hot type. Also, they are more robust than them. Also, in the hot cathode type, we studied that the filament get burned out very quickly. Here, it does not burn very easily. And also in the cold cathode type, the process gas is not subjected to any thermal stress, because in hot cathode type, because process gas we are having the electrons emitted due to the ionic emission, but here no thermal stress is put on the process gas. So also it is having very high sensitivity than the hot type. Okay, so these are the advantages. Now if we see its disadvantages, its disadvantage are lower accuracy, non-linear output signal, now in this high potential field is present, so due to the high voltage operation, gas take up is caused. Now in this tube also there are some polymerized organic contaminants, and these contaminants are going to affect the measurement readings. So in order to remove these contaminants, periodic cleaning of the electrons and vacuum chamber is required in this cold cathode type. So these are the disadvantages of the cold cathode type of ionization vacuum gauges. So these were the two types of the ionization gauges we studied here. So in this video, we studied about the ionization gauges, the types of ionization gauges, their construction, their principle of working, their advantages, disadvantages, along with their applications. So I hope that this topic is now clear to you. Thank you.